Good morning. So we are going to continue to talk about arclen today. So last time we have seen one of the example, which is on the parametric equation. Today we are going to see some other example. So let's do this one. Suppose we want to find the arc length of a function given by x is equal to y to the 3 halves, where y is from 1 to 0. Right. So now this time this is not a parametric equation or a parametric curve. It's a function that's given by x is equal to something of y. So in this case, we will need to use a different formula, the third formula. And so now L is given by the integral. The bounds for y are given. It's from 0 to 1. So you don't need to determine it by solving some equation like what we did yesterday. And the integrand is the square roots of dx dy. So it's f prime of y squared plus 1, then dy here. Now f prime of y is simply 3 halves times y to the 1 half, using the power, the formula for the power function. And this is equal to, its square will be equal to 9/4 times y plus 1, and then dy. So now we get the expression of the arc length of this curve. And all we need to do is just to solve this integral. So again, for this example, we can still use the what's it called? The U substitution. But the difference between this example and last example is that you only have y here. It's not like t squared. It's not t squared, which is what we did yesterday. So for this kind of integral, when you have square roots of some first order function, because there's only one order, the order of y is just 1 inside the square roots. For this kind of function, you can just let u be whatever it's inside the square roots. That's 9/4 times y plus 1. So then from here, so then du is equal to 9/4 dy. And if you divide both sides by 9/4, you get dy is equal to 4/9 du. So, right, and then there's a bound for u. Bound for u. When y is equal to 0, which is the lower bound for y, u is equal to 9/4 times 0 plus 1 So it's equal to 1. And when y is equal to 1, u is equal to 9/4 times 1 plus 1, and it's equal to 13/4. So this will be the lower bound for u, and this is the upper bound for u. So L, which originally is 0 to the integral of square roots of 9/4 y plus 1 dy from 0 to 1. Once we use the u substitution, u is equal to 9/4 times y plus 1. You get the bounds will change for u. So now the lower bound will become 1, and the upper bound will become 13/4. And the integrand, because we let u is equal to 9/4 y plus 1, which is the function that's inside the square roots. So this is just u. And dy, we have dy is equal to 49 du. So it's 49 du here. And now, right. And then this is just equal to 49 times u to the, there's one more here, times 3/2 u to 2/3 times u to the 3/2, right, from 1 to 13/4. This part is from the integration of square roots of u. And square roots of u is just u to the 1/2. So it's similar to the example we did yesterday. You get 2/3 times u to the 3/2. And then this guy, once you plug in both endpoints, you get 49 times 2/3 times 13 to the 4, 13/4 to the 3/2 minus 1 to the 3/2, and it's equal to 8 over 27 times 13/4 to the 3/2 minus 1. And again, I am happy with this final answer, but if you want to like further simplify this expression, or you want to plug in this number in your calculator and get a decimal number, that's fine with me. That's fine by me. So any questions on this example? If you have any questions in the future, just feel free to ask. You can either type your questions in the chat, in our chat, or you can just ask. And remember to unmute yourself before you ask questions. Okay, let's see another example. We have one more formula. So let's try an example. So let's try to find the exact arc length of the curve. Y is equal to x cubed divided by 3 plus 1 over 4x, where x is between 2 and 1. So as you can see in this example, the arc or the curve, it's given by a function y is equal to f of x. So we will need to use the second formula for this form of arc. So the arc length, L, it's straightforward. It's equal to the square roots of 1 plus f prime of x square dx. And the bounds for x are given by the questions, which is from 1 to 2. So you get this integral. And then y is equal to, because y is equal to x cubed divided by 3 plus 1 over 4x. So y prime, or f prime of x, is equal to x cubed minus 1 over 4x. It's equal to x squared minus 1 over 4x squared. So the integral becomes the integration of square roots of 1 plus x squared plus x squared minus 1 over 4x square, and the square roots of whole thing dx from 1 to 2. And so at first glance, there's no easy way to do this. So we can try to simplify the expression inside the square roots. So first need to simplify the square part. And you get 1 plus, so it's x squared minus 1 over 4x square. So this guy is equal to x to the 4 minus 2 times x squared times 1 over 4x squared, and plus 1 over 16x squared dx. Please, if you have questions.
Yeah, I have a question, sorry. So can't you not just cancel the square root with the parentheses square? And
No, you can't.
You can't?
No, you can't do like, so this is one of the common mistake. If you have square roots of x squared plus a squared, you can just take the square roots on each parts. They're not the same. So
Okay.
it's not equal to x plus a. So you can see it from like 1 squared plus 2 squared. So this guy should be equal to square roots of 5, but the square roots of 1 squared plus square roots of 2 squared is equal to 3. They are not the same number.
Okay.
You can check it in your calculator.
All right. Thank you.
So any other questions before I proceed? So you can't do, you can't directly just cancel the square if you have a sum or something. And there's not much choice for us here. So we can, the only reasonable thing to do here seems to be just try to simplify the squares and see what happened next. So now if we keep simplify it, I get 1 plus x to the 4. This turn x squared and x squared cancel, and 2 cancels the 4. And this term will become negative 1/2 plus the last term, 1 over 16x squared dx. And now this becomes the integral of square roots of 1 plus, well, just x to the 4 plus 1/2, because 1 minus 1/2. 1 minus 1/2 it gives you 1/2. And then plus 1 over Yeah, this is to the 4, my bad. Because originally it's 1 over 4x squared. So its square is 1 over 16 times x to the 4. Then dx here. So note that this expression here is still not simple, and we don't really have, I believe we don't really have a formula for this form. But if you write 1/2 as 2 times x squared times 1 over 4x squared plus 1 over 16x to the 4 dx. So this guy is 1/2 if you cancel x squared and 2 1 over 2, and you get 2 times 1 over 2 times 1/4, which gives you a 1/2. So these two expressions are the same. So it's an equation. And if you write it in this form, you will realize this guy is actually, this integrand here, the whole thing, is actually a complete square. So let me make more modification here. So 1/2 is equal to 2 times x squared times 1 over 4x squared. And the first term, x to the 4, is x squared square. The last term, 1 over 16x to the 4, that's 1 over 4x squared square. So now you can see that the first term is something like just a squared. Second term is 2 times a times b, and the last term is a b squared. Here, a is x squared and b is 1 over 4x squared. So it's a complete square. Then we can write it as 1/2 of square roots of x squared plus 1 over 4x squared square dx. And then before we cancel the square and the square roots, we need to make sure that this guy is a positive number. So right, when you have a square roots of something square, what you will get should be the absolute value of it, not the original number. It's not equal to a. It's equal to a when a is a positive number. If a is a negative number, then you should get the absolute value of a. So in this case, it's similar. We should integrate the absolute value of x squared plus 1 over 4x squared dx. But fortunately here, both terms, x squared and 1 over 4x squared are squared, something squared. And both of them are greater than or equal to 0. So, so both x squared, this is a square term, and 1 over 4x squared, this is also a square term, are non-negative. So the sum of these two terms must also be non-negative. So the absolute value doesn't make any difference here. You can just write x squared plus 1 over 4x squared. It is true for this example, but it may not be true for other example. And then now we can write it as x squared plus 1/4 x to the negative 2 dx. Then use the integral formula, you get this is 1/3 x cubed minus 1/4, 1/12 times x to the negative 3. Right. And integrate it from 1 to 2. Then you plug in the number, you get this is equal to 8/3 minus 1/4, 1/12 minus the difference between 1/3 and 1/12. Right, this one's not 1/12. The first one is, let me see, that's 1/96. So x to the -3. So it's 2 to the -3, which gives you 1/8. Multiplied by 1/12, you get a 1/96. Second term is 1/12. And then this guy is equal to 255/96 minus 1/4. So it's equal to 231/96. And again, decimal numbers is allowed here. Please.
Just really quick, could you go back 2 pages really quickly? I think I missed writing something down.
Okay. I will post the lecture video after the class.
Okay.
So
gotcha.
On exams, do we get to use calculators, or do we need to learn how to simplify at a certain point on our own?
Calculator is allowed.
It is, okay.
So if you are you don't want to simplify this, you can just use your calculator. Just input all those numbers and get a decimal number.
Okay, awesome. Thank you.
Any other questions?
I have a question.
Sure.
Could you go back 1 page? I might be wrong, but shouldn't the second term have become x to the -1 instead of x to the -3?
X to the -1. Wait a sec. Yeah, I think you're right. Yeah, my bad. So thank you for pointing it out. So this should be -1/4 times x to -1. And this will be, now this time this will be 1/8, and this is 1/4. Yeah, now this one is easier to calculate. And right. Go back here. So the first term, 3/8 minus 8/3 minus 1/8. Second term is 1/3 minus 1/4. First term, that will be 60, that's 64 divided by 24 minus 3 divided by 24 minus 1/12. So this gives you 59 divided by 24. Yeah. Yeah, my bad. Any other questions? Or any other mistake you want to point out? So I make mistake from time to time, especially arithmetically. If you find something unusual, just let me know. Okay. So let's move to the next section. The no. The average of the function. Yeah, average value of the function. Of a function. So the average value is you must be familiar with the average value. If I give you a bunch of finite numbers, like if you are given some number like for example 1, 2, 3, maybe all until 100, the average value of these numbers, you would just add all of them, like 1 plus 2 plus 3 plus 100, and then divided by the number of terms. And this value, which should be 50.5, we'll call this an average value of this of these numbers. But what is the average value of a function? So recall the definition of the integral, or how we introduce the integral. We first try to divide the interval into a lot of subintervals. And then in each interval, we find a sample point. We just find a sample points, like for example, this is x1 star, x2 star, x3 star, all the way to like xn star. And the average value of function will just call the limits as n goes to infinity of the sum of the value of the function f of xin, xi star, because we want to find the average value of the function. So it's reasonable to take to calculate the value of the function at those sample points. Then we calculate the sum, just like what we did for a finite collection of numbers, then divided by n. And when you let n goes to infinity, you will realize this guy is actually equal to 1 over b minus a multiplied by the integral from a to b f of x dx. And this is because if you recall the definition of integral, which is I over n f of xi star. Right. The integral b f of x dx is equal to the limits as n goes to infinity of the sum of I from 1 to n f of I star multiplied by delta x. And delta x here is actually b minus a divided by n, because there are n subintervals, and the total length of the interval is the difference between the endpoints. So it's b minus a. And right. And then if you divide it both sides by 1 over b minus a, you get this. And this is exactly how we define the average value of the function. And this guy, it's denoted by f average, sub average. the definition is straightforward. So let's just try to apply this definition to one of the example. Suppose we want to find the average value. Average value of the function f of x is equal to 1 plus x squared on the interval -1 to 2. So the average, by definition, is equal to 1 over b minus a. In this case, b is the right endpoint, which is 2. The left endpoint is -1. It's 2 minus -1. And the integral of f of x, which is 1 plus x squared, dx, from -1 to 2. So this guy is equal to 1/3 times the integral of 1 plus x squared, which is x plus x cubed divided by 3 from -1 to 3 to 2. So it's equal to 1/3 times 2 plus 2 cubed divided by 3 minus -1 minus 1/3. And this guy is equal to, let me see. Right, this is equal to 1/3 times 6, so it's equal to 2. So the average value of the function f of x on this interval is 2. So the formula is straightforward, and there's nothing much here, but there is an important theorem in calculus that is related to this definition, which is called the mean value theorem for integrals. So you have seen the mean value theorem for the derivative. I think we just call it mean value theorem back then. Here, there is another mean value theorem for the integral. If f, the function f, is continuous, so this is a prerequisite for the function. It must be continuous. Otherwise, you cannot apply the mean value theorem. So if this function is continuous on the closed interval a from a to b, then there exists a number c in this interval ab, such that the value of the function at point c is equal to the average of the function. Or equivalently, sometimes you would do this, f of c times b minus a is equal to the integral of f of x from a to b.
Is there another name for this theorem? It seems really familiar.
I don't know. I don't remember. There's another name for this theorem.
Oh, okay.
Usually you just
ask.
call it mean value theorem for integrals.
Okay.
So let's see what this theorem actually tells you. Let's first see this prerequisite here. The f is continuous. For a discontinuous function, the easy one, the step function, you would call it Heaviside function in some case, step function. Or Heaviside function. Y is equal to h of x. And if you pick, like, for example, if you pick the interval to be -1/2 to 1/2, and you calculate the average value of it, let's say y average is equal to the integral from 1/1/2 minus -1/2, so it's b minus a, times the integral of h of x from -1/2 to 1/2 h of x dx. And since this function is 0 on this part from -1/2 to 0, and it's 1 from 0 to 1/2. So the integral of this function is actually the area under this curve from 0 to 1. So this is actually just 1/1 times 1/2, which is the area of this rectangle. It's a rectangle, although I draw it, it looks like a square here. And this is equal to 1/2. The average value of this function is equal to 1/2, but because it's a step function, the function can only take either 0 or 1. So there's no c such that h of c is equal to, there's no c, y average. And this example tells you that the discontinuous function, the mean value theorem for integral can only be applied to a continuous function. Or at least it's continuous on the interval you are interested in. Right. And then if you look at so this is a counterexample. For this continuous function, just this continuous function. And next thing I'm going to talk about is the geometric interpretation of mean value theorem. For integrals. So if you look at the last expression we have for the mean value theorem, the equivalence expression, f of c times b minus a is equal to the integral of ab of f of x from a to b. On the right-hand side of this equation, this integral actually is actually just the area under this curve f of x from A to B. So let's just assume everything's nice here. There's f of x is a positive function on the interval AB. So the integral, so then this integral represents the area under this curve. And then on this side, fc times b minus a. So we call that the c in the mean value theorem is a number between a and b. So it's actually in this interval a to b. So then let's suppose c is here. Then the right-hand side, the left-hand side of this equation is actually just the so this point is c of c. It's actually just the rectangle, the area of the rectangle, whose height is f of c. So this is its height, and the width it's b minus a. And the mean value theorem actually tells you that the area of the curves is the same as the one of the rectangular region. See, this is C. So the area of the curves, the area of the area under the curves on this on the interval A to B is the same as the area of the rectangular region that's whose height is given by f of c, where c is a point between A and B. And f of c, this height here, f of c, is equal to the average of the function. Any questions here? So basically, it tells you exists some points between A and B such that f of c is equal to f average. And usually the questions that is related to the mean value theorem requires you to find the average. Or sometimes, I think in practice, sometimes you can only measure the average, not the instantaneous change or instantaneous value of the function. Sometimes you will use the average to estimate the integral. But we are not going to do that in this class. Right. So let's see an example. Let's try to find the value of c in the mean value theorem for integrals for function f of x is equal to 1 plus x squared on the interval from -1 to 2. So the translation of this this question is that you want to find a c such that c is on this interval such that f of c is equal to f of average. So f of c is straightforward because we know what f of x is. F of c is simply 1 plus c squared. And f of average, by the definition of the average value, that's 1 over 2 minus -1 times the integral from -1 to 2 of f of x, which is 1 plus x squared dx. And this guy is equal to 2, because this is the same integral we have calculated in example 1. So in order to find C such that it's the points that in the mean value theorem, just need to let f of C is equal to f of average. So f of C is equal to 2. So basically you need to link these two equations, and you get 1 plus C squared is equal to 2. And from here, C is equal to, well, C squared is equal to 1, and C is equal to plus minus 1. But the question doesn't end here, because in mean value theorem, we require C is on the interval -1 to 2. So we need to check whether plus or -1 is on this interval. So but in this example, since -1 is between -1 and 2, so it's in this interval, and 1 is also in this interval. So both value of C are valid. Both C values can be our C. In RC in the mean value theorem for integrals. And geometrically, right, so the function was 1 plus x squared, and it's from -1 to 2. Geometrically, it says that the curve from the area under the curve 1 plus x squared is the same as the area if we use -1 as the height of the rectangle, and the interval as the width. Then the area, all these areas are the same. And of course, there's another one here. This is 2, this -1. Then the mean value theorem ensures that all these area, all the area of the shaded region are the same. Any questions? So we'll continue on Friday. There will be a lab tomorrow. Right, you just need to join the corresponding lab section. I haven't checked the cameras, but I think the RTA will post the Zoom sections for the lab tonight, or well, at least before the lab tomorrow. So you can join the corresponding lab tomorrow. We will meet Friday.
Excuse me, I do have a quick question.
Sure.
So it's just like some notation that I've never seen before, but in the line that says like we require C, like what's the notation after C? Yeah, that.
That's belong to.
Okay, thank you so much.
So which just means C is a number between -1 and 2.
Okay, thank you.